Hi everyone, this is Hunter Gashai. I previously created the presentation about fertilizers in drinking water, and I'm going to talk a little bit about the chemistry of fertilizers themselves. First, I'm going to talk about the chemical composition of fertilizers. Fertilizers consist of three main macronutrients: nitrogen, atomic symbol N, phosphorus, atomic symbol P, potassium, atomic symbol K, and three secondary nutrients: calcium, atomic symbol Ca, magnesium, atomic symbol Mg, and sulfur, atomic symbol S. All of these are natural pure elements that can be found on the periodic table, as we learned in the semester of chemistry. And you can also learn their properties from the periodic table. First, I'm going to talk a little bit about nitrogen. Nitrogen is the most widely used fertilizer and most vital to plant growth. It is usually synthesized from ammonia, NH3, natural gas, and nitrogen from the air. This is usually what nitrogen fertilizers look like. It is usually in the form of ammonium nitrate. The second most common type of fertilizer and the cause of eutrophication is phosphorus. Phosphate rock is reacted with nitric acid, HNO3, to produce phosphoric acid, H3PO4, and calcium nitrate, CaNO3 2. This mixture is then applied to plants. This is the nutrient that causes eutrophication in bodies of waters, as algal blooms consume the phosphorus and then grow out of control for the particular system of water that they are affecting. This is a visual of what phosphorus-based fertilizers look like. I'm going to talk a little bit more about eutrophication. This is when a high concentration of phosphate PO4 in water promotes rapid growth of cyanobacteria, also known as algae, which deplete oxygen and produce harmful toxins. This is caused by runoff of fertilizers created by chemical labs. Chemists can test water quality, especially where algal blooms are occurring, to discover what is causing these algal blooms. It is most likely that they discovered there are high concentrations of phosphate in the water that is affected by algal blooms. This is one way that chemistry problem solving can apply to the real world. And here's just a few ways that chemistry can help us solve the problem of fertilizer in drinking water. Environmental chemists can analyze water sources using molarity and concentration techniques to provide surveillance of polluted bodies of water. This can help us prevent water runoff by applying several other preventive techniques, such as nutrient management, if we discover that a body of water is susceptible to nutrient runoff and fertilizer runoff. Other chemistry methods, particularly analytical methods such as stoichiometry, which we learned this semester, can assist farmers in using the correct amount of chemical fertilizers. Farmers can discover how much nutrients a certain plant needs to reach its full potential, and then use analytical techniques to discover the correct amount of fertilizers. This prevents excess fertilizers from being washed away by precipitation and polluting drinking water. Thank you so much for listening to my presentation. I hope you learned a little bit more about the chemistry of fertilizers and how chemistry can be used to help solve this environmental health problem.